Hey YouTube. So we have arrived at 2025 and I've not been making a video for like 3 weeks or something. And the reason was kind of twofold. So first of all, this was my first real holiday after I sold my company. So that was a little bit of a celebration. And to be honest, I was also kind of stuck a little bit playing the early access version of parts of Excel 2. But now I need to get back to business and make videos and so on and so forth. I thought it would be a good idea to make a quick video. I need to set up a new root server, and of course I will do that with NixOS. And I thought it would be a good idea just to take you along the journey and just to show you how I actually use the things I have showed you in the NixOS playlist in practice. So this video will be about setting up a new root server for my own services, and I hope you will learn something when you follow along. I will not explain all of the concepts I am using here in detail, so for that please refer to the NixOS Flake video series where I explain most of the stuff you will see here in detail and how that works. So let's dive into it. The base for the new server configuration is my personal Nix Flake. I will link to the Git repo in the comments. This flake basically reflects all the principles and things that were also discussed in the NixOS Flake series. So for those of you who have followed this series, you will find a lot of familiar things here. So the first thing I would like to do is I go to my hosts folder here, and here in my Flake I have the host definitions for the different machines I am configuring with this Flake. And of course I need to add a new machine in order to set up my new server here. And the way I do this here is by using a Flake template. Basically I just use the command nix flake init and then -- template, and then I give it the URL of my Git repo, and I can just execute this. And now you can see the Flake template has been executed, and I put some documentation into the Flake template, so we have some next steps output here. Here it says that we of course need to rename the host name and make some simple changes to configuration.nix here, so I will just do that. And this host will be named Atlas. And then I go to configuration.nix and put in the host name. The second value I want to put in here is the networking host ID. And as it's stated here in the little documentation for the Flake template, this can easily be done with OpenSSL, rand, and then hex and 4 digits. So I will just execute the command here, and I get back a host ID I can use here in my configuration. And now this configuration will be good enough to set up the basic server here, and just to go through it a little bit. And just let me go through a couple of key points here. So at the top here, we import disco config and the hardware configuration. And the disco config will basically hold the partitioning scheme we will use when we make the installation with NixOS Anywhere. And on the hardware configuration, we import the guest tools for virtualization because the server is a virtual server. And then we just have some basic configuration here. So in programs, we have nh as a program that helps us run Nix commands. And from the services side here, this server will have Traefik as a reverse proxy enabled, and we will also install Podman in order to run Docker containers on this machine. And in order to push this configuration to the new machine, we of course need to edit our flake.nix file here. And here I can just copy the configuration from my Helios system and put it in here and name this Atlas. And of course refer to the Atlas configuration here. The other thing I need to modify here is I need to go to my users folder and I need to create a user configuration for this specific host. And in this case, I will just duplicate the configuration for Helios here and just name it Atlas. And then I will just add all the changes to my Git repo and make a Nix Flake check to check if my Flake evaluates correctly. And as you can see, the Flake has evaluated correctly. There are some warnings because on Nix packages, the services PostgreSQL extra plugins option has been renamed, but that I can fix at a later time. And here there's a conflict because I have garbage collection and NHClean enabled at the same time, but that's also not critical. And that I can just fix later on. And now we can basically start doing the installation. And the way the new machine is set up right now is I have just booked a root server at a hosting company and they have installed Debian Linux by default and sent me the IP address and my root password. And what I can do now is I can just quickly log in, and in order to use NixOS Anywhere and let Disco take care of the partitioning, I need to know which block device is used here. So I will just list all the block devices, and you can see the block device is VDA. And when I head back to my configuration here and look at the Disco config, you can see this is already correct. So this depends really on the provider. Some have VDA, some have SDA, and you basically just need to change the device here in order to let Disco take care of the partitioning of the machine. And now that we got all the parts together, we can use NixOS Anywhere to just override the Ubuntu system and to make a NixOS machine out of it. So we use nixrun, NixOS Anywhere, and then we refer to our Flake configuration and give the SSH credentials. So at the end, we put root at and then the IP address. And now we can just execute this. And this would just fetch everything it needs to set up the new system. And now it will prompt me for the root password. And now it will start overriding the system here. And dependent on the internet connection and how fast the packages are built, it will take around about 10 minutes to set up the whole machine. And of course, this is done the Nix way without any user intervention here. And now it's finishing up the installation here. And it's waiting for the reboot of the machine here. So this is all done now. And when I try to log back into this machine with SSH, I first get a warning because the host key has changed, and that could be a potential security issue. But in this case, we knew what we were doing, and so we will just need to quickly change the known hosts file here. And you can see down here, we have the IP address of our new server, and we can just save this. And now we try to log back in. And I want to trust this machine. And now it's prompting for my root password. And when I give it my root password now, I won't be able to log in here. The reason is because there is no root user anymore. And the Debian installation has been completely replaced by NixOS. So the old credentials my host has sent to me don't work really. What will work instead is, of course, my user configuration I have sent over by installing it with NixOS Anywhere. So the whole installation process has set up the server, and it also has, of course, set up the user and everything that belongs to that. So all I need to do now here is to create a SSH configuration to log in. So I can just edit my SSH config file and just go to the end and just take this host entry and change it. And of course, I will need to put in the IP address, and then I can save it and just clear this out and just log into the machine by its configuration name. And now you can see I am logged into my machine. And when I print my working directory, I am in my user folder. And with this configuration, we have also installed some basic services here. So for example, when I enter Podman here, you can see Podman is available as an alternative to Docker. And I also have a Docker alias for Podman. This is also configured. And what we also have installed with the configuration here is Traefik as a reverse proxy. So when I have a look at the status, you can see that the Traefik web server is installed and is set up as a systemd service, but it doesn't start right now. And that's an issue that comes with secrets management. We will fix that in a minute. So as you can see, we have a fully working NixOS system here, and I can just log out. When I have a look in my Flake here, I am referring to secrets here. So first of all, I have the secrets for my main user, and then I have secrets for Traefik, which holds the configuration that Traefik needs in order to do a DNS challenge with GoDaddy here. And we have defined the secrets in the secrets.nix file. And as you can see here, the secrets that are defined are on system and on user level. And right now, the new server is not allowed to decrypt the secrets. And in order to fix that, we need to make a new system entry here. And for that, we will need the host key of our new machine here. So what we can do now is we can make an SSH key scan here and have a look what keys are available on this machine. And I will just copy over this key here. And then I will just define the key for Atlas here. And we also need to add Atlas to the systems list here. And as you can see here, for all the keys down here, all systems and users are allowed to decrypt these keys. And now I have saved this file. And in order to be able to decrypt this with the system key of our new machine, we need to rekey our secrets here. I'll just clear this out here. And this is basically done with hnix rekey, and then you give it a key that is allowed to decrypt the secrets. And that's, in this case, the user key I have defined up here. So I can just execute this. And I have made a mistake here, because we will need to have the key type in front of the actual key here. And now the secrets have been rekeyed, and the new machine is now allowed to decrypt the secrets here. And now I can just rebuild the system configuration. So I execute NixOS rebuild switch and then Flake and our Flake config. And I give it a target host and ask it to use remote sudo. So I can just execute this. And now it will rebuild the system configuration. And part of rebuilding the system is decrypting the secrets so they are available. Now I will just log back in. And now I can just use the sudo systemctl start, and then we start the Traefik service. And when we now have a look at the status, you can see that the service is up and running now, because the missing part was really the secrets file that was defined in the configuration. And now this is working. And now I want to go further into some more configuration of the system. Actually, the changes I will show now could have been in the system configuration in the first place and could have been installed with the whole system install. But there are some points I think that are quite helpful to know. So what we will do now is we do some Podman or Docker configuration, and we will declare some Docker containers to be part of our NixOS configuration. And I will just quickly show you how I do that. So in our host folder, we have a services subfolder and a container subfolder. And in the container subfolder, I have a default.nix. And the way this will work is that in the container subfolder, I will create a Nix file for each container I want to be part of my system configuration, and I will just import it in the default.nix file here. And the way I have organized my containers is that all external facing containers that are available over the internet are part of a Docker network named web. And in order to have this automatically set up by NixOS and to eliminate the need to create the network manually, I will just add a simple option here, which will just be an activation script for Podman. And this will basically use the Podman CLI to check if the network exists. And if it doesn't exist, it will be created. And of course, in order to make this work here, we will need to have lib available here. And now we can save it. And when I now rebuild my system configuration and head back to my machine, I can just have a look here. And as you can see, when I use Podman network ls to list all the available networks, I have the web network enabled. And when I inspect the network, you can see here is the IP range I have defined in my activation script. And this is also configured as an internal network here. And before I start defining my containers here, I want to first of all install Postgres and MySQL as database systems, because the way I work is I have the database systems available on the host, and I don't want to spin up different iterations of MySQL and Postgres in Docker containers. Because the big advantage having it on the host is I can just easily back up all databases that are used by the containers here. So on my services folder, I will just make a file and name it postgres.nix. And I have already prepared the configuration here. I will just quickly go over it. So on the Postgres service, we enable TCP IP, and here we define which networks are trusted by the TCP IP connection for Postgres. And for example, we allow localhost to be completely trustworthy, and we also include the Podman network as trustworthy that we just set up here. And here I have just an initial script. So in this case, I already know I want to run a BaseRow container here, and I will just make the initial script, create the BaseRow database and the BaseRow user for the system. And this is quite convenient when you build up a completely new system here, because in the initial script, you can just set up databases and users and so on and so forth. And down here, I have a backup service here that will run each day and back up the BaseRow database. And for MySQL, we do something similar here. So we create a MySQL.nix file here. And this I also prepared. And in this case, we take MySQL and not MariaDB. And the reason for that is I use Ghost as my blogging platform. And for example, the statistics on the Ghost blog, they break when you have a drop-in replacement like MariaDB. So in order to have full functionality on Ghost, I need to have MySQL as a package here. I already set up the databases here, and down here, as on the Postgres definitions here, I create a user and I also manage the privileges for the users here. And here's a little mistake. Just quickly fix that. And I forgot to put the backup in, so I will just put it in here. So this will also have a backup service now, so the databases are backed up every day and add our Ghost database to the array of databases here. And after creating these Nix modules, I will go into default.nix here. And of course, I need to import MySQL.nix and Postgres.nix and save it here. And now I add all the new files to my Git repo, and I can just rebuild my system and send the configuration over to the machine. And there seems to be a problem in my configuration, so I go to MySQL.nix, and the problem here is that I have put the ensure databases under settings, and this needs to be outside of settings here. So I will just quickly fix that. And now we try again. And I still got an error here, and that is basically the same problem as before. So I will just need to move it out of the settings section here. And now we try once more. And now the configuration is working and will be applied to my remote machine. And when we head back to our system here and have a look at the service status, you can see MySQL is running here. And when I have a look into MySQL and list my databases, you can see that the Ghost database and the Matomo database have been set up here. And of course, we can do the same for Postgres. So when we check for the status of Postgres, you could see this is also running. And when we use the Postgres tool here and list our databases, you can see the BaseRow database has also been set up. And we can also have a look at the users. So you can see the BaseRow user has also been created here. And the next thing I would like to do is to set up some Docker containers here. So we will set up one Docker container for BaseRow and one for Ghost. And in order to do this, I will create a new file, name it baserow.nix. And I have already prepared the contents for the file. And here we basically define an OCI container named BaseRow. We refer to the image on Docker Hub, and we give it an environment file that is in our secrets folder. This environment hub file, for example, holds credentials for the OpenAI integration in BaseRow and also the credentials for my SMTP server in order to send notifications to users. And here we assign the ports and we assign the volumes, and on the extra options, we refer to our Postgres server that is running on our host, and that is available under this IP address. We assign a static IP address, and we ask the container to join the network web. And down here, I have some extra configuration for Traefik. So we will set up a load balancer for port 3001. And then we create a router with the subdomain and define the certificate resolver here. Yeah, and that's basically it. Actually, the Traefik options could be also included into the Traefik.nix file, but I like to have this in the container modules. For me, it's very convenient to have the whole configuration for this one container in one place. And that's why I'm also doing the Traefik configuration within my container module here. And of course, on the default.nix, we need to import BaseRow.nix here. And now we can add the new files to our repo here and start rebuilding our system configuration. And it seems like I didn't include a secret yet. So just have a look at our secrets folder. And there's no BaseRow environment file here. So we will need to include this. First of all, I go to secrets.nix and I will just copy this line here. And add the BaseRow file here. And then I will just create a new file with the hnix command. So we will nix run hnix and then -e and give it the file name. And I would identify with our private key here. And I will just put in the contents of my file here. And now this is available. And on the secrets.nix file on our host folder, we will also need to make an entry here. So we'll just quickly copy this one like this. And we have added new files, so I need to add them to the repo. Now we'll try once more. And now we are able to rebuild the system correctly. Now the system is rebuilt. And when we are back into our server system and we look for a status here, we can see that the Podman container for BaseRow is running. And when we have a look at Podman here, you can also see that this is working. And to be honest, I had a small mistake in my Postgres module. Actually, I thought enabling TCP/IP would also enable the port on the firewall, and that is not the case. On a lot of Nix modules, when it comes to enabling network functionality, the TCP/IP ports are automatically opened in the firewall. But in this case, it isn't like this, so I added a networking firewall allow TCP ports for the default for Postgres. And now when I go to my subdomain, I have BaseRow running on. You can see I am greeted with a brand new BaseRow instance. So that is working. And of course, the domain has been automatically processed by Traefik. So I made a DNS record on my domain host to point to my server IP address. And as we have installed Traefik, this will automatically obtain a certificate for this subdomain and for this server. And here we have a secure connection. And now I will just create another container and I name this one ghost.nix. And this is very similar to the BaseRow container really. So I will just copy the code in here and here we have a named container ghost here and we pull it again from Docker. Here we have the port assignment and here's a small typo. And here we assign it a static IP address and we refer to our MySQL database from the host and also join the network web. And here we have the Traefik configuration and this of course needs to be 3002. And that's basically it for this module here. And of course we will need to include it into our default.nix here. And here I will just need to import ghost.nix. Then I add all the files to my repo. And now I can just rebuild my system configuration here. And the same mistake again, I did not add the secrets file for Ghost, so I will quickly do that now. So first of all, we go back to secrets again. I will just copy this line here, name this for ghost. And then I go back to the secrets. Just copy these lines here. Also name this for ghost. And the same we do here with the file name. Now I will just create the environment file. And now I need to add it to my Git repo. And now I can rebuild my system configuration. And when I have a look at the status of my ghost service, it is up and running. And also when I have a look at Podman, we can see that the service is up and running here. So this was an actual example on how I configure a new server here. And of course, all of the configuration I have built out here could have been already finished. And we could basically just set up the whole thing just with the Nix Anywhere command and just replace the Ubuntu machine with the fully built out NixOS machine. But I wanted to show the part with the databases and the Podman container configuration. And of course, there's still some more work because I have my old server still running and I didn't move any data. So for example, I need to export the MySQL databases and the Postgres databases on my old host and import them on my new host in order to have all the data available. And the same goes for the Podman volumes that also need to be moved over to the new server. But still, I hope you find this video useful, and this is a more practical video in comparison to the Nix Flakes series, where we were talking about the very basics on how to build a configuration like this. I will link the full configuration in the description, but please be aware this is the Nix Flake I am always fiddling around with. So what you see in this video might change very quickly because as I work on my systems, also my configurations will evolve. So if you have any questions, feel free to just drop a comment and I will do my best to answer your questions. So that's it from me today. Have a nice time.